Hi, welcome back. So we are in chapter 1 introduction, and that is to discuss threats to conclusion validity. Now, the basic idea before you start learning about all the set of tools that you need to understand in order to do analysis to your data set to reach out to some answers to your research questions in the form of a certain valid conclusion, you need to be aware of a number of issues that might cause kind of a threat to your conclusion validity. And the idea starts, as we have learned from our first book research, all the steps lead us to define number of variables, right? Or we call it a space of variables. And basically what we are waiting to learn at the moment is to learn steps or number of tools to do a number of analysis on this space of variables. And one of the major factors that analysis can help me out to define is to investigate a relationship, whether a relationship exists between those variables or not. And there are two possible reach out from this analysis. The first one is to say, yes, actually I found there is a relationship exists. Alternatively, you might say, no, actually I found no relationship exists between those variables. Now, what is the issue? The issue is once I split this to look at the reality. Now imagine in the reality, when you have suggested, yes, there is a relationship, the reality actually there was no relationship. Or other way around, when you suggested there is no relationship, there was actually, yes, a relationship. This is the first kind of issue you might need to be aware of. And you have to understand once you are building up your analysis, you might want to take into consideration this margin of kind of error, if you are well. Now, the second problem, which is not very much far from this, concerning what's so-called the decision matrix. Let me show you exactly what that looks like. Now, basically, we have come to understand the definition of hypothesis from our first book. And we know now there are two types of hypotheses. The first one, we call it the null hypothesis, or it's denoted as H0 or H0. And the second one is we call it the alternative hypothesis, denoted as H1. Now, the actual technical definition of them and what they are actually meant by from an analysis perspective, this is what we shall learn in the following sections. But for now, just let's know that there are two types of hypotheses. The first one, we call it the null hypothesis and the alternative hypothesis. In reality, there are two possible scenarios. The first one, that this null hypothesis happens to be true. That means the alternative, it is false. Now, the second scenario is completely the opposite, that the null hypothesis actually is false, alternative is true. Now, we're going to give names to these two scenarios in reality. If the null hypothesis is true, we'll call it the scenario of alpha. If the null hypothesis is false, we'll call it the scenario of beta. Now, in your conclusions or the answers that you might reach out to, there are two possible scenarios. The first scenario, to accept the null hypothesis. That means you are actually rejecting the alternative one. Or other way around, actually you decided to reject the null hypothesis, and that means you are accepting the alternative one. Now, what we want to do, just like before, is to mirror the reality to the conclusion and the conclusion to the reality. Now, if you have come to the conclusion of accepting a null hypothesis when it was true, that means you are doing the right things. Otherwise, if you have come to reject a null hypothesis when it was true, you are committing the first kind of error. We call it error type 1. Now look at the other side, beta scenario. If you have come actually to accept a null hypothesis when it was false, you are committing the second kind of error. We call it error type 2. Or the things that we want you to do actually is to reject a null hypothesis when it is false. So as you have seen the two different scenarios for your conclusion, you might reach out and mirroring to the reality of alpha scenario and beta scenario. We always try to make sure we are at the diagonal of this decision matrix. Now, what can be done and what we should do to avoid these two types of issues that cause kind of a threat to our conclusion validity? That is to learn about some kind of statistical power component component while you're doing your analysis. Now, those components actually taken into consideration, this margin of error happens in both scenarios. Like in this scenario happens in here, and the second scenario, the margin of error happens in this region here or in this region here. It depends on the scenario of alpha and beta. And that's exactly what we shall discuss in the following section. I will see you then.